Welcome to States of Matter. In this class, I will explain how we can classify the different states of matter so that you can apply this knowledge in the classroom for discussion and experiments. As a brief introduction, the videos you can see are of water, chosen because of its abundance and the ease of which I can show you it changing from liquid to solid and then eventually to gas. Now these are the three main states of matter, but of course in its greater abundance than all the other states of matter combined is plasma as well. To first understand the different states of matter, we must have an understanding of particles. Particles is a term used by scientists to describe the building blocks of matter. Now, imagine that you have a large rock and a hammer. You would be able to break the rock into smaller stones using the hammer. If you were to get your hammer and hit those stones again, you would be able to break them into gravel. And then once more, using your hammer, you could break that gravel into sand. And then finally, with a good deal of effort, you would be able to use your hammer to break your sand into silicon dioxide. And at this point, you would be able to break your rock down no further. And this non-breakable powder is an example of particles. The different states of matter can all be explained by how the particles interact with each other. If the particles are stable and uniform, the state is solid. If the particles are all moving around and yet staying close together, the state is liquid. If the particles are all flying around and are separated, the state is gas. Let's have a look at the similarities and differences between solids, liquids, and gases. Let's start with solids. Now, does a solid retain a fixed shape? Yes, fixed shape. It has a fixed volume. I can't compress it. And it will not flow. Now a liquid. The shape of a liquid. Well, the shape of the liquid is the same as its container. Same as whatever container it's in. Its volume is a fixed volume. its compressibility. It cannot be compressed. And as we can see, water flows easily. Gas can be a little more problematic to conduct experiments with, because the majority of gases are invisible and those that aren't are quite dangerous to work with. But with the use of syringes, we can still demonstrate the properties of gas. So shape, gas will fill the container, in this case a syringe. It will flow. As we can see, it flows from one syringe to another. And it will fill the volume of a container. The only question left is gas's compressibility. And as we can see here, if I bung up the ends, we are able to compress gas quite a lot.